The first really important idea is that the particles in a solid are tightly packed together. In fact, the particles are all touching each other and there are no spaces between them. The particles in a solid cannot move, but they can vibrate, and we're seeing that here. I'm showing you here the particles in a solid, and I'm going to heat one end like this. The heat gives energy to the particles, so they vibrate harder. Because all the particles are touching, the vibrations now pass across to the particles next to them like this. So that means that the heat energy is now making its way along the solid as the vibrations spread from one particle to the next. And now the heat has fully spread right along the solid. Remember that heat moves by conduction through solids, and that's because the particles are very close together, so vibrations can easily pass between them. Now, I said at the start that metals are really good conductors of heat, and you need to know why. Metals are solids, so the particles are packed close together, and vibrations can easily spread between them. But metals have another special property, making them great conductors, and that is that metals have got free electrons. These free electrons can move, and they can carry energy like this, and that makes metals really great conductors of heat. Lastly, we're going to take a look at insulators. Insulators reduce heat movement by conduction, and I've got some examples for you here. This is an insulating jacket, here's a polystyrene cup for hot drinks, and here's a polystyrene box to keep food hot. All of these are good insulators, which means that they reduce heat movement by conduction. You need to be able to explain how insulators reduce heat movement, and it's all to do with how the particles are arranged. So I've shown you here how the particles are arranged in an insulator, and you can compare them with the particles in a conductor. The really obvious difference is that the particles in an insulator are not tightly packed. In fact, they have massive spaces in between them. And what that means is that when the particles vibrate in an insulator, the vibrations cannot be easily passed onto nearby particles. In other words, the heat energy cannot easily move through the insulator.